Good afternoon. We're going to start the fourth session now. We're going to take a look at the gvSIG application and the different uses of it, and how in certain cases these apps generate new tools for gvSIG. On the one hand, we're going to have speeches about the application in archaeology, which is a field which has got a great potential, I think, for technology SIG. It perhaps is a field in which it's a bit difficult to get it going, to get the technologies and applications going, but we've got to be braver and braver in the use of them. Afterwards, Andrea will show us new tools for management and forestry management, and then we'll have a different speech about the application of gvSIG in forecasting police prevention, in police predictions, and how we've got an integration with the R statistical package. So we're going to start with the speech by Alfredo Cortel and Pilar Escribá, who are from the University of Valencia. They're archaeologists and they come from the Department of Prehistory and Archaeology from the University of Valencia. And the name of the speech is Archaeometry and Georeferencing with gvSIG in an open-air site, the MassDIS 2015 campaign. So whenever you want, go ahead. Good afternoon to you all. Sorry, I don't hear. Thanks. Yeah, that's better. All right, hello to you all, with Alfredo Corte and me, Pilar Escribá, and we're going to present to you the communication called Archaeometry and Georeferencing using gvSIG in an open-air site, which was in the MassDIS campaign from 2015. We're going to tell you how archaeological methodology is used by our department and by the university team here in Valencia, which is made up not only ourselves, but by Bien Bernabeu, Lopez and Orozco. It's in the Alicante site. MassDIS is an open-air site village, which is inhabited by some of the initial farming communities which are set up in the Iberian film. We're talking about 8,000 years ago. For us, it's extremely important to understand the excavation and the stratification, to stratify the different parts of the Earth and to take a look at the geological materials which are inside. As it's open air in a glacier along the side of a mountain, this site is extremely vulnerable to erosion and certain processes which could alter the stratification. So therefore, it makes things a lot more difficult to understand them, and the gvSIG is a tool which we can use to make things a lot easier for ourselves. The excavation is a long-term project which has been carried out since 1998, so the amount of data we've got is extremely wide, and each year we've got to provide new data in a way which is going to be coherent and is related to previous campaigns. Also, archaeology is instruction. Each time that we open up a layer of earth, it's as though we opened up a book, a layer of a book or a part of a book. Nobody else is going to be able to see this. So therefore, the reconstruction, virtual or digital reconstruction in this case, of the site is extremely important, both for ourselves, who we have a certain continuity, for all other archaeologists and historians who are going to come in the future, and we'll have to understand the site as well. After this, Alfredo will talk about our methodology.
Buenas tardes.
Hello, what we're going to talk about mainly is the way in which the geographic technologies can be used in archaeological work. As Pilar has said, one of the most important elements is the stratigraphy, which allows us to understand how we relate different, which we're going to call ORS, how they are related between themselves. So all the SIG tools have made a great innovation in fieldwork. For example, one of the most important things is the use of the total station. But what's more important for us here is the digitalization of the data. So we're working with gvSIG to do this. This enabled us to get a register which is much more useful and reliable if we compare with their prior registers, which had different formats and were difficult to understand, let's say. And also, Pilar also have to say that the fact that the excavation means the destruction of the site in itself means that visualizing this is extremely important for it. And for this, we need to take geographic data, which is extremely important because it allows us to reconstruct it in a virtual mode almost all the site. Now, with all of this, we have nowadays we have excavations, and with the technology, with software, leave it open software we have. With this type of data, we can understand much better and much quicker how the excavation is working, and we can pass information on to the future researchers in a much better way. So we're going to explain now some of the processes which we have actually used in this excavation. To start with, how we draw these is we take points with a total station, obviously, and after this we create in gvSIG. We drew a polygon layer. Then we've got with the Z coordinate is to directly introduce CSV site into the gSIG, and then it allows us to label the polygonal layer. And this one means that we can see them, although we may not be able to work with it on a geographical level. With X and Y, we can see the Z coordinate, which is extremely important because the depth of the elements for us is extremely important. Here we've got an example of a reconstruction, a partial reconstruction of the section 104. We're going to do 4 stratigraphic areas. I don't want to go into too much depth here, but we could add or take away layers as much as we want to so that we can understand how they interrelate to each other, which then provides great benefit to archaeological research. We haven't included here the teats to not make matters too difficult, but we could include them and therefore be able to observe what depths certain units are at and how they relate to other layers, areas. In the field, one of the operations which we did was to, each time we recovered an artifact in the site, we took with a total station point, and we could find out whether it was ceramic, and after we have included a CSV of different points, which we've given different colours, which according to the element which was found. For example, here we can see the silex is in the north part, while the pullament or the ceramics we can see in the southern part. If these elements are important or not for archaeological research will have to be checked on with the other disciplines which are working within the excavation, but it also helps to make things easier for dealing with the archaeological data. Here we have an example of how there is distribution of all the recovered elements in the 104 site. We've got relative use here because we cannot meet timelines from different points, but it does help us to understand that we can mix different units and to understand if a certain element, a certain item could have a different distribution to the material which has been found. So one of the most important elements for archaeological, for referencing with gvSIG, the georeferencing is unique, can be done in a microspatial way, can be referenced in space. We can reference what is most important to us, which we find inside the site. So the points of referencing are the points which are offered to us, the possibility of manipulating data in a way, let's say, not in a non-destructive way. It's also very important to eliminate errors, cumulative errors in archaeology in the past. In fact, at present in certain areas, we can say the way that methodology was triangulation points, but it could last 8-10 years, the excavation, and we could get cumulative errors drawing the same zone with different exposures, and we could ruin the data. In other words, we could make the data management could be much more difficult. But using gvSIG's system, this doesn't happen with the methodology. As we're talking real coordinates, we don't have cumulative errors. So we've got a process of results. But before this, I'd like to talk a little bit about the importance which the georeferencing has in archaeological sites. Although the the most visual side of archaeology, the most one, is the actual intervention itself, the excavation itself, the excavating. The most work is done in data management, data mining. What we have to do is manage very wide volumes of data. And we've got different diverse materials, and sometimes this means they're not in the best state conditions, which makes things more difficult. Now that we've got these materials, things can work is much easier in this field. Although we're in a multidisciplinary way, of course, there's going to be much more complexity involved. What we have done is we want to explain archaeological points in this speech, which could be useful for anybody who wants to apply them. And the way which we've georeferenced things with gvSIG has been to select, first of all, the unit, of course, which we want to georeference. In this case, we've got a combustion structure. And after taking the photograph, what we do is we've included not less than 10 points for whatever wants to be georeferenced. And from these points, we could say it's absolutely important, essential that they're set and very visible. So the fact but what is really important in this case is that they are very visible, because if not, it's extremely difficult to work with them in the georeferencing. Now that I've said this, we've created layer shape and a sort of process for georeferencing. Therefore, we've got the unit totally found in space, located in space. Here we have some examples of future work, of post-work. We've got the elements with georeference. For example, in the combustion structure, we've got a layer on top of this where we have marked both the limits and the elements which are of interest to us. We've introduced, the same way as we did in the past, the Z coordinates to observe the depth of the unit. We've also tried to show the georeferencing, vertical georeferencing, which has been corrected, by the way. To do this, we've had to substitute and implement in the gvSIG coordinates X by Y, and we've had to replace E with Z. So we've got vertical georeferencing, which means that from here we can then include, as it's visible, we can include what units they are. So with this, we have both vertical vision of the units as a natural, virtual and a natural vision of these things. To finish this part now also, I would like to, we've also included in a layer shape the combustion georeferenced, and we've compared it with materials, as we had in the past, which could appear in higher layers and lower layers. We've attributed colours, not because to the unit, and we can see, for example, that in the units which are next to each other, especially in the north part, in the combustion part, we can see there's a lot less in the southern part. So in the upper layers, they are distributed mainly in the south and very little in the northern part. So once again, this could be archaeologically interesting or not. What we've done with this simply is to make things a lot easier to draw conclusions, to provide information which can be looked at in a different way, to complement the real significance which the distribution of materials may have, if there is anything. It has to be complemented with all the other multidisciplinary elements which are involved. In this case, we have said that one of the main tools is to help data mining, to make it easier, because it's an extremely high amount of information we have here. And finally here, and I'm going to finish this speech now, Pilar is going to go and explain to us some general apps of gvSIG. Right, to conclude this communication here, I'd like to summarize the main applications which we've been commenting about during all the work here, which are related to the archaeology. In spite of contingencies which Alfred has commented about, the Z coordinate or the need to update software for Mac, there are many advantages for us in using this tool. Some of them are the collection and conservation of accurate data, application and citing of everything which you find on a macro, micro, spatial level. We have an accurate, a precise reconstruction later on, which explains what we've seen and what we have done. We've got to use a common scientific language which is easy to exchange within the community. We've got to have rapid addition for this, and that every year, or with each investigator, researcher who is working can provide new data, new information. The fact that it's software, free software, is very important for us. Today in the presentation we spoke about the sovereignty of technology. We go a little bit beyond this, and we think that this tool and all the tools which are free are very good for democracy, make democracy with all software useful for all researchers. And we'd like to finish things up by talking about the great team who've worked with us from the Department of Prehistory and Archaeology from the University of Valencia, and to the lovely people in Penagala, where our archaeological site is, their town hall, who have helped us in all ways related to the archaeological site. Also, thanks very much to the organisers of gvSIG for giving us the opportunity to be here, and thanks very much to all of you here for listening to us in such a difficult moment.